In a previous assignment, we calculated for each SKU the average annual sales, the average daily sales, and the standard deviation of daily sales. And we were calculating that data for use in some inventory management models. Now, previously when we were dealing with that sales data, we tended to think of that sales in terms of dollar amount, like total revenues from sales. But for inventory management models, the sales need to be in units, like number of units ordered, not dollar values. And so we're going to assume those sales are in number of units, not dollar values. And what we're going to do, we're going to bring those data into Excel to create inventory models to determine exactly how much to purchase and at what time using two different inventory models. There are two types of inventory models we're going to look at. One is the economic order quantity when demand is continuous and constant. And the other one is the economic order quantity model when you have stochastic demand, meaning demand is random. And in the first model there, the first thing we'll calculate is Q star, which is the number of units of the SKU that we're going to purchase every time we make an order. The second thing will be T star, which is the amount of time that passes between each orders, where time there is measured in fractions of a year. And then we have the inventory reorder point. That's the level at which inventory has to fall to, at which point a new order is made. In the second model, we need one additional equation. That's going to be S star. S star is the level at which inventory has to fall to then trigger a new order where you then order Q star units. As a reminder of how these models work, with the economic order quantity model with continuous constant demand, for each SKU you order Q star units whenever inventory falls to Q star times L divided by T star. And in the economic order quantity model with stochastic demand, for each SKU you order Q star units whenever inventory falls to S star. This is a spreadsheet you made in the last assignment, so I'm going to start here. And always the first thing I do is I copy the original data and I'm going to paste special it into a new sheet, paste special values. Just in case I mess something up in the sheet I'm working with, I can always go back and get those original values quite easily. And then what I'm doing here, I'm just getting numbers into a format that I like, easier for me to read. I know I'm going to make a model in the spreadsheet, so I'm going to make some room to the left and above that data. And just remember, these inventory models, they require the sales data to be stated in number of units, like number of units purchased. And so we're going to pretend those data are in that time. And then I'm going to go ahead and set up the spreadsheet like this. I'll stop it here for you to do this. And for my model, I'm going to want a series of columns showing the SKU, the value of D, Q star, T star, S star, things like that. So I'm going to go ahead and make a new row which contains the SKU, which I just get from the data on the right there. I'm going to need the big D in the equation. That's just the expected sales for a whole year or annual demand. And remember, we've already calculated that in the data. So we just go across and select it. In our equations, the values of R, H, L, and K, those are numbers that I have to assume. I have to give the model those numbers. So we call those parameters. So I'm going to put those in a cell, and I'm going to give each of those variables a name so I can easily call it in formulas. It makes our life much easier, as you'll see shortly. For the variable R, I'm going to name it VARR. I'm going to name the variable H, VARH, variable L, VARL, and the variable K, VARK. Now I'm going to just assume some values for these variables, and these are the values that I want you to use in this assignment. I'm going to assume ordering costs are $15,000 per order. The holding cost is 2 cents per unit per year. The lead time is going to be 12 days, and the safety factor we'll use in a little bit. We're going to go ahead and start with our equations. We know that Q star is the square root of 2 times R times D divided by H. So we enter it like this, where R is entered as VARR because that's what we named it. And so that's going to give us Q star for every SKU. I'm just getting the numbers in a way that I like. Now I'm going to do T star, which is the amount of time that occurs between each order, and T star, and T, of course, there is specified in fractions of a year. I need another column because then I'm going to put our inventory reorder point. Value of 0.1051 simply means that about a tenth of a year passes between making orders. Next, we need our inventory reorder point, the level at which inventory has to fall before we make a new order of Q star units. And here we know the formula is Q star times L divided by T. And we have to be careful because the lead time above is stated in days, but L in this equation needs to be stated in fractions of a year. So we divide the lead time of 12 by 365.25. And as we copy and paste these formulas down, we now have all the numbers we need to be able to manage inventories for each SKU in this particular model. And these may be values that I put in a computer program that tells people when to order and how much to order. The EOQ model, when we have stochastic demand, we just need one more value. We need one more column, so we need S star here. So I'm going to put in S star. And now, so this is economic order quantity model with stochastic demand. And we go in and just use our formula for S star here, which is always going to be we take the average daily sales times lead time. So average daily sales times var L, the lead time in days. Here lead time has to be specified in days, plus your safety factor, and we'll go back and put a value for that in a minute, times the standard deviation of daily sales, times the square root of lead time. And we haven't actually put in a value for the safety factor yet. We're going to put in a value of 2. That's always the value we're going to be using in this class. But if you're in a situation where you think you need to have even more safety stock, you want to be more risk averse, you can make it 3. You can make it whatever you want. And now we have our S star for each SKU. And now we're done. So for every SKU, we have all the information we need to management in the EOQ model with continuous constant demand, if that seems like the most relevant case. But we also have the information to manage it using the EOQ model with stochastic demand, if we believe that is the case. And what we might do is there might be a supply chain management software where you go in and you put the value of Q star, you put the inventory order point, you put the value of S star, and then there's an automated system to monitor inventories as they go. And sometimes the systems are even designed to make new orders automatically without anybody being involved.